Hi, I'm Richard Smith. I'm a ham radio operator. My call sign's K0KEX, and I'm part of the KC Hart team in Kansas City. This morning we're putting together some information on the SignalLink device that we'll use within the hospital facilities. In the time of disasters, we need tools in our toolbox for digital communications. In the KC Hart facilities, we have two. Today we'll try to show you how APRS and FLDigi is used for these communications. APRS for short messages and FLDigi for more complex messages. We're going to start with FLDigi, and it will take a little time for FLDigi to load. As you see, as it comes up, we have two other programs that are interfacing with it. We'll talk about them at a later time. One is FLAMP, which is a messaging device, and we'll minimize that. And we also have FLMessage, which is a message form device that interfaces with the FLDigi modem. The software that I have opened up and loaded is the FLDigi modem program. This is an interface between your computer through the SignalLink to the radio so that you can communicate in digital functions. These digital functions I'm discussing are operating modes such as PSK31, or we could use RTTY, but whatever function we use to get digital communications. We can also have keyboard-to-keyboard functions. And how that is done is through this FLDigi modem. At this particular time, I'll point out that this is the receive buffer, this is the transmit buffer, and this is the waterfall function of this FLDigi modem. We'll first go into the configuration files for this device, select operator, and you'll identify your facility in your location. I have preloaded St. Luke's at Smithville. We'll do that again. You can capitalize or however, and I'll use STL SMI. That identifies the St. Luke's campus in Smithville. You can also put in an operator name, but it is not necessary. You can leave that blank or you can put it in. The QTH, which is the location of the facility in Hamtalk, is Smithville, Missouri. And we can also find the grid square locator, which we'll put in this case Echo Mike 29QK. Enter, and at this time we'll save that configuration. Now we can go back up on this same screen to user interface, which is identified as UI. And that immediately takes us to the macro function. The various macro functions that you see right here on this screen give you certain preloaded accesses or sections that you can preload yourself. You can also select the scheme of the particular way the macros are laid out. While we're in this, there's several things that I would like you to also click on. Load last macro file on startup, which is important. Highlight this with a check mark. Display macro file name on startup, check that one also. And prompt to save macro file when closing. This is very critical and we'll discuss it at a later time. Again, save and go back up to the waterfall functions. This gives you choices here to change your waterfall colors and so on and so forth. I chose to leave them in the default mode. While we're discussing the default modes, you have an option of restore defaults. I would suggest that unless you want to completely restore every default that you have, do not use restore defaults, and we'll discuss this time and time again. Always hit save. You can go up now to your various modems and you can see the various modems. And when I talk about modems, the function that this device will operate, it will operate in CW and the various functions, Olivia, PSK that you've heard me discuss here previously. We'll go over to the rig function, and the default functions that are set up here are already pre-selected, and I believe they'll just be fine. Hit save again. Now we'll go to the audio. This is critical here because we can go in and select different audios for the capture and different audios for the playback. In using the SignalLink device, you're going to use USB audio codec, C-O-D-E-C. That is the function. You want to select that. In playback, you have the same options, and we want to use USB audio codec also. Again, save. We'll scroll on over to miscellaneous, and this takes us into some of the functions of the configuration files for the NBEMS function. We have pre-selected where FL Message is stored as a communications program, which we'll discuss here in a few moments. To find that FL Message that we have loaded, we'll go to Locate. We'll go up and select this local disk, C drive. We'll go into the program files. We'll open the program files, and we'll scroll down to FL Message in the program files. We have several here that I have preloaded. The latest version is 2.0.8, so we will select that, and we'll see that it's the executable files listed here as file types. We'll open that, open it again, and we'll see that we have now the path to locate the FL Message program. It's in C /program files /FL Message and the FL Message executable. Again, save. And remember never to hit restore to false unless you know exactly what you're doing. Some of the other features in this particular configuration page are Sweet Spot. And you notice that this one is preloaded for 880 Hertz for CW, 1000 for RTTY, and 1500 for PSK. We'll save that, and we'll go directly to the waterfall function to demonstrate what that sweet spot means. If you notice down in the lower left-hand corner, I've selected BPSK 31, and the default here is 1500 Hertz on the waterfall. I'll go up and select a different operating mode while you review the waterfall position. When I click on CW, you'll notice that the waterfall position changes to 880 Hertz, and that's a readout of this audio function across this waterfall. This is 500 Hertz, 1000, 1500 Hertz, and so on. So we'll go back and pre-select again PSK 31, and you'll observe that it now moves over to 1500. If I select a different operating mode, which is a faster mode, such as BPSK 125, you'll observe on the waterfall that the waterfall changes in space, which indicates the bandwidth that will be required to send the data in that particular operating mode.